In this video, we're going to take care of the periodic table and trends review section of your midterm study guide. So number one, write the full electron configuration for neon. I noticed this phrase right here, electron configuration. And electron configuration is essentially our code that tells us the most likely place to find an electron in an atom's electron cloud. And there are 4 rooms that we could find an electron in. They are S, P, D, or F. And each of these rooms is able to hold a different number of electrons. So S can hold 2, P can hold 6, D can hold 10, and F can hold 14. And so we always fill up our S rooms first, then we follow with our P rooms, then D, and then F. Now, rooms are not just out there floating around anywhere. Rooms are always on floors, and atoms have floors in their electron clouds. There can be up to 7 floors, and the first floor is always closest to the nucleus. Well, on every floor, you have to have an S room. It can be the only room on that floor, or it can be the first room on that floor. If you have multiple rooms, then you'll have to go S and then P and then D and so on until you get to the end of your floor. Now, when it says write the full electron configuration, that's essentially like you starting at the ground level. You're right next to the nucleus. So the order for electron configuration that we want you guys to memorize is 1s followed by 2s, then 2p, then 3s, 3p, 4s, and then 3d. These numbers are not in order. We can see that once we get to 4s, it drops back to 3d, and that's how we know that these numbers do not go in order. The order that we fill is what floor are we on, first, second, third, or fourth, and then what room do we fill, S, P, D, or F. And you do this until you run out of electrons. So neon is 10. That'll be 1s2, 2s2, because S can hold up to 2. Then next in our memorization would be 2p. P can hold up to 6, and we have 6, so we will say 2p6. To write the full electron configuration for chlorine, we would say that has 17 electrons. We would say 1s2, that would drop it down to 15. 2s2, that would drop it down to 13. 2p6, dropping it down to 7. In our little note over here, after 2p is 3s, which can hold 2, and we have 7. And last but not least would be 3p, which can hold 6, and we have 5. So this will become 3p5. If you have to write the full electron configuration for nitrogen as an ion, then we have to do a little bit of work beforehand. So nitrogen has 7 electrons on its own. But this ion tells me that I have 3 more electrons. So I'm going to go plus 3, which means that I have a total of 10. So again, starting at 1s, 2 takes it down to 8. The next part of our template is 2s, which will take us down to 6. After 2s is 2p, which will drop us down to 0 because p can hold up to 6. If we have to write the electron configuration of a magnesium ion, Mg plus 2, that's a little different. So magnesium has 12 electrons and protons, but a magnesium ion is telling you that you have 2 more protons than electrons. So we need to subtract the 2 so that we can say that there are 2 more in the protons, which means that again, we have how many? 10. So this will be 1s2, 2s2, 2p6, just like it was for nitrogen. Question 5. Sodium is going to catch on fire when it reacts with water. Which electron configuration represents an element that will react with water in a similar way? So if I want to react or behave in a similar way, then that means that I'm looking for electron configurations that are in the same family as sodium. Well, sodium is going to be an alkali metal. So which of these electron configurations represent elements that are alkali metals? We are going to determine the relationship of those by adding together the exponents and the noble gases. So for instance, we have 2 plus 2 plus 2. That is going to take us to element 2 plus 2 plus 5 is going to take us to element 9. Neon has 10 electrons, plus 2 plus 5, that's going to bring us to 17. Element 9 is fluorine, element 17 is chlorine. That's going to be an example of a halogen. So not the right answer. In the next option, 2, 4, 10, 12, 18. And helium is bringing 2. Plus 2, 4 plus 6 is 10. And that's going to bring noble gases. In part C, 2 plus 2 plus 6 plus 2 plus 6 plus 1, that's going to give us 19. And helium is going to bring in 2 plus 1 more from after that, which is going to be 3. These are both of our alkali metals because 19 is potassium and 3 is lithium. These two electron configurations would catch on fire when they reacted with water, similarly to sodium. For this problem, we're going to want to use our periodic table to help us out. Let me get this out of the way. So the element for electronegativity that we want to memorize is F. The closer we are to F, the higher the electronegativity. For ionization energy, we want to remember He. The closer we are to it, the higher our ionization energy. And last but not least, the atomic radius is Fr. This is the largest atom on the periodic table. So if I'm talking about the alkali metals, those are going to be located very far from fluorine. And if we're very far from fluorine, then that is going to be indicative of low. Here is our fluorine. And here are our alkali metals. They are very far apart, so the ionization energy would be very, very low. Same thing for alkaline earth metals, as they are also very, very far away. The halogens are going to be in the same family as F, so that makes them extremely close with a very high electronegativity value. And last but not least, for the noble gases, we're going to put none. This is the only trend that the noble gases are not included in. For ionization energy, for the metals, they're going to have the very similar suit as our electronegativity, low and low. Our ionization energy value for halogens will be very high, and it will also be very high for the noble gases. The atomic radius for the alkali metals will be very high, as well as the alkaline earth metals. But once we make it over to the halogens and the noble gases, we are going to say that they are very, very low or small. Which of the following statements is true for the ionization energy of the calcium atom? It is lower than that of barium. It is lower than that of potassium. It is higher than that of krypton, or it is higher than that of strontium. We need to pay attention to ionization energy. We're going to focus on comparing calcium and anything else to helium in order to answer this question. So which of the following is true? Is calcium going to have a lower ionization energy than barium? So here's calcium and here's barium. Because calcium is closer to helium, it would have a larger ionization energy compared to barium. In our answer, it says that it would be lower, so that is not true. Is the calcium ionization energy going to be lower than potassium? So here's calcium again, and now here's potassium. Again, calcium is closer to helium, meaning that it is going to have a higher ionization energy value. In part B, it says lower, so goodbye. Is it going to have a higher ionization energy than krypton? So calcium is right here and krypton is right here. For ionization energy values, we can consider noble gases, and so krypton, being much closer to helium, would have a much higher ionization energy value, not calcium. Finally, it must be because calcium is higher than strontium. If we take a look at where they are on the periodic table, we can see that they are both alkaline earth metals, but because calcium is closer to the top, it is closer to helium, so it is technically our correct answer. In question 8, we have a couple of different models. Which of the following models would represent the most reactive nonmetals? So go ahead and take a look at this, pause the video now, and select the models that you think would represent the most reactive nonmetals. So model 1. Model 1 has a black column in this position, and that position is the halogens. The halogens contain fluorine at the top, and that is the most reactive nonmetal on the periodic table. So model 1 would definitely represent. Model 2. This is a Lewis dot structure. The dots represent the number of valence electrons. This is 1, 2, 3, 4, 5 valence electrons. This is not going to represent something that is going to be a most reactive nonmetal because it is not the same family as the halogens. Model 3 is an electron configuration. To determine the element it represents, we add up all the exponents, and that is going to be 17, and that is another halogen. In model 4, we get an oxidation number of +1. That is not going to be a nonmetal because nonmetals need negative charges. And then in model 5, again, electron configuration, 2 + 2 + 6 + 1 is going to represent an alkali metal. So, in our practice problem, which of them is going to be the most reactive nonmetals? This is going to be the halogens. And that's going to be models 1 and 3. In question 9, which halogen is more reactive then, chlorine or bromine? So let's take a look at our periodic table. Chlorine is going to be right here, and bromine is right here. And the most reactive nonmetal is fluorine. So because chlorine is closer to fluorine, it would be the most reactive. So let's go ahead and get rid of bromine. Now, is halogen more reactive because it's smaller or because it has a lower electronegativity value? Let's see which statement is true. When we take a look at our elements on the periodic table, it is clear to see that chlorine is closer to fluorine, which would make it have a higher electronegativity value than bromine. However, chlorine being on top of bromine means that there are less energy levels in the picture. 3 versus 4. And because 3 is a smaller number, we would know that chlorine is going to be more reactive because it has a smaller atomic radius. In question 10, oh, my bad. Write this in. The most reactive nonmetal is fluorine. The closer I am to it, the more reactive I am. But which of the alkali metals would be more reactive? So when we take a look at the alkali metals, that's going to be everything in the first group, except for hydrogen. Well, which of these is going to be the most reactive? That's going to be francium. Because it's the largest on the periodic table, it makes it the most reactive because it's the furthest from its valence electrons, which makes them very easy to lose, aka react. Out of our options, we have lithium or we have rubidium. Which one of those is closer to francium? Lithium or rubidium? When we circle them up on the periodic table, we can see that because rubidium is closer to francium, it is going to have a larger radius and be more reactive. So we can get rid of lithium. And is it B, C, or D? It's going to be answer choice C because it is a larger atom. So now let's write this in. The most reactive metal is francium. Question 11. What is the common oxidation state of the alkaline earth metals group 2? This phrase right here means ionic charge. Because alkaline earth metals are in group 2, they have 2 valence electrons, and they will always lose those valence electrons to fall back to a noble gas. Well, if I lose 2 valence electrons, I will have more protons. And this means that my charge should be positive. So we'll remove the negative 2's. Because there are 2 valence electrons, we know it is positive 2. But again, that comes from the loss of those 2 electrons. So our best answer is B. Would neon normally be expected to form compounds? So neon is a noble gas. And there are 2 things that we need to remember about noble gases. Number 1, they have 0 electronegativity. Because of that, they have 0 reactivity. So would they be expected to form compounds? The answer is no. And that's because it has an outermost level that is full and unreactive. So the best answer is C. In questions 13, 14, and 15, we are challenging you to write in a few things about the different trends. The atom with the biggest atomic radius is francium. So we need to write increasing or decreasing on each of these arrows based on how they are pointing. And why is this element the largest, and how do other elements get small? Let's start with writing increasing or decreasing on our arrows. If the arrow points towards the side or top or bottom that the element for that trend is on, we would write increasing. So this is going to be pointing towards francium's side, so it would be increasing, I and C. This is pointing down where francium is located in the bottom half. So again, once it points to it, it means it's increasing. Now, why is francium the largest? Well, one more time, it has the most energy levels because it's on the 7th period of the periodic table. And it also has the least amount of valence electrons, 1. Elements are going to get smaller by adding more protons and electrons to the same period, aka row. So when you do that, you're pulling in more charges that are oppositely attracted, protons and electrons, and those opposite forces are attracting to each other and pulling each other closer. So that is what makes the atom smaller as a nonmetal. There are more protons and electrons. Question 14. The atom with the highest ionization energy is He. Again, we're going to write increasing or decreasing. Well, He is right here on the periodic table, and the top arrow is pointing to it, and the bottom arrow is pointing to it. So then they must be increasing. What does this mean about the element with the highest ionization energy? This means that helium is the hardest element to remove an electron from. Question 15. The atom with the highest electronegativity is fluorine, F. Let's write increasing or decreasing on each arrow. Our top arrow is pointing towards fluorine, so increasing, but our bottom arrow is pointing away from fluorine, so that must mean that this would represent the decreasing direction. What does it mean about the element with the highest electronegativity? It means that fluorine has the best ability at pulling in electrons to form bonds. The last question in this video is number 16. Which element below is most likely to have the lowest atomic radius? When you see the lowest atomic radius, you should think that we are asking you about the smallest atomic radius. And the smallest atomic radius is going to be one that is further from the atomic radius element, which is Fr. An element in the alkaline earth metal family is extremely close to Fr because Fr is an alkali metal. So alkaline earth metals are going to be large, not small. An element that has 6 valence electrons is going to be like something like sulfur or oxygen. And while I do think that it is smaller than the alkaline earth metal family, let's keep going to see what other elements we have. An element with an electron configuration of 2 plus 2 plus 6 plus 2 is telling me that this is 12, which is magnesium. Magnesium is kind of close to the alkali family, so that's going to make it the largest or a larger atomic radius, not lowest. So answer choice D says that the element is completely unreactive. That would make it a noble gas. And a noble gas is furthest from Fr. That makes it the smallest. Even smaller than an element with 6 valence electrons. If you need help with the Unit 2 periodic table content, because you're really trying so hard to get together your notes, your assignments, your practice to do well in the midterm, see any chemistry teacher. We're so happy to help you. We want to work with you. Please just check in with us whenever you need us.